So hello all. Now we see the relations between the properties of characteristic properties of the any waves. Already we know what are the major properties of the waves. One of the main properties of the waves are wavelength. Okay. The main properties of waves are, we know that there is wavelength. Wavelength, that is lambda. So can you guess? Can you remember this definition? So what is the lambda? So the lambda is nothing there. The distance between the two successive crests or two successive troughs in a wave is called the wavelength lambda. We know that different units are also there. Next, the main property is wave frequency, or simply we can say frequency, that indicated with nu. Okay, not exactly v, just it's somewhat crass. It is frequency nu. So what is the frequency? The frequency is nothing but the number of waves passed through a particular point in 1 second of time. Next, the one more property is wave number. Wave number is nothing but indicating nu bar. So what is the wave number? So it is exactly the number of waves present in any unit length in 1 centimeter or in meter. How many waves are present exactly? That is known as a wavelength. So already we know what is the velocity. Okay, so velocity is indicated with c. Already we know velocity. The general definition for velocity is the distance traveled by the any object. But here we are discussing about the wave. The distance traveled by the wave in 1 second of time. The distance traveled by a wave in 1 second of time is called velocity. So it is having fixed value because their velocity is exactly equal to the velocity of the light, that is 3.0 into 10 power 10 centimeters per second, or 3.0 into 10 to the power of 8 meters per second. Okay, so the what is importance of this velocity is so all types of radiation, if you see, with visible region, ultraviolet region, infrared region, microwaves, all types, we know that even gamma rays, that different types of radiations are differ in their frequencies and in the wavelengths and in their amplitudes. But what is the equal? All are having a equal in all times is their velocity. They are having same um, value velocity. Okay, now we see the relations present between them. Okay, so there is a standard relations are there. With the help of that we can write other definitions also, other relations also. So it is given nu is equal to, that is c by lambda. Nu is equal to c by lambda. So what is c? We know everything. Next, so nu bar is equal that is 1 by lambda. Nu bar equals 1 by lambda. So here so apply this, say it is the first formula, it is second formula. So the second formula, apply the second formula in first. Apply second formula in first. What happens? Nu is equal to c into, this is c by lambda, c into 1 by lambda. 1 by lambda plus 2, we can write nu bar. So c nu bar. Okay, so these are the standard relations between the wave properties. So if you see, we can write some other relations also, means which are useful in the problems. So what is the relation between, this is nu means frequency wavelength. So this is present in the denominator, this is present in the numerator. So both are having inversely proportional. So the equation 1 implies, we can write with the help of 1. All c is a constant, we know that c value is a constant. So nu proportional to 1 by lambda. Okay, means they are reciprocal. In the problems, it is useful to compare the frequencies and the lambdas. Inversely proportional, so we can write lambda mu 1 by mu 2 is equals lambda 2 by lambda 1. Okay. Next, by taking 2, equation 2 implies also we can write nu bar. Wave number is also inversely proportional to wavelength. Wave number nu bar, okay, nu putty bar is also inversely proportional to lambda. So here also for comparison, nu 1 bar by nu 2 bar equal to exactly inversely lambda 2 by lambda 1. So here again with the help of so from equation 3, so okay, nu and nu bar. So C is a constant. By removal of constant is equal, you can put proportionality. So both are present in the numerator. Nu proportional to nu bar. So nu 1 bar by nu 2 bar equals nu 1 by nu 2, as they are having a directly proportional relation. So these are the main relations between the wave properties, and there is a no perfect relation in the amplitude. Okay, but here very important one. So writing the C value. Okay, the writing C value is important. So we know that C is velocity. What is value in CGS method? It is having a 3 power 10 centimeters per second. In SI method, it is having 3.0 into 10 to the power 8, so meters per second. So these are the main relations between the properties of waves. Okay. So let's see Planck's quantum theory. So Planck's quantum theory, actually it was proposed by in the name itself is there. So Max Planck. So first we see the main points in the this theory. The Max Planck quantum theory mainly is introduced to explain the black body radiations. Okay, next, according to this theory, the black body radiations mainly, so no any radiations, the radiations emitted by any object, already we said ఏదైనా కాంపౌండ్ కానీ గ్యాస్ కానీ ఏదైనా సాలిడ్ కానీ హీట్ చేస్తే సో అది ఎనర్జీని అబ్జర్వ్ చేస్తుంది, సమ్ అమౌంట్ ఆఫ్ ఎనర్జీని అబ్జర్వ్ చేస్తుంది, సమ్ అమౌంట్ ఆఫ్ ఎనర్జీ రిలీజ్ చేస్తుంది. ఓకే, ఆల్రెడీ వి సెడ్ ఇట్ టోటల్ డిపెండ్స్ ఆన్ ఇట్స్ నేచర్. ఓకే, అయితే it is observed that the emitted radiations by any object is due to the vibrations of the charged particles present in it. దాంట్లో ఏదో ఒక చార్జ్డ్ పార్టికల్స్ ఉంటాయి, ఆ చార్జ్డ్ పార్టికల్స్ ఇట్లా వైబ్రేట్ అయితే కాబట్టి దే రిలీజెస్ సమ్ రేడియేషన్స్. హౌ దే వైబ్రేట్ మీన్స్ on heating only they vibrate. On heating they vibrate, on their vibrations they releases some radiations. It is according to the Planck's quantum theory. Next, one more theory, the energy emitted nothing but the emitted radiations, the energy emitted nothing but the emitted radiations energy is not in the continuous manner. So already we know that every radiation is consists of some energy. Every radiation consists of some energy. Absorbed radiation or releasing radiation, it is having some energy. So that energy of the radiations are released. The energy of the radiation released by an object is not in the continuous manner. So not only emitted radiation, the absorbed radiations, the absorbed energy is also not in the continuous manner. సో ఎక్కడ అబ్జర్వ్ అయింది ఎనర్జీ అంటే సో మనం రేడియేషన్స్ రేడియేషన్స్ ఎమిట్ చేయాలంటే ఏదైనా ఆబ్జెక్ట్ నుంచి కంపల్సరీగా దాన్ని ఏం చేస్తాం, మనం హీట్ చేస్తాం. విత్ ద హెల్ప్ ఆఫ్ ఎలక్ట్రిక్ కరెంట్ హీట్ చేయొచ్చు, ఆర్ విత్ ద హెల్ప్ ఆఫ్ డైరెక్ట్ హీటింగ్ చేయొచ్చు మనం. సో అట్లా హీట్ చేసిన తర్వాతనే మనకు వైబ్రేషన్స్ వస్తాయి, వైబ్రేషన్స్తోనే అక్కడ ఎనర్జీ రిలీజ్ అవుతుంది. సో వీఆర్ హీటింగ్ దట్ ఆబ్జెక్ట్ మీన్స్ నథింగ్ బట్ ద పార్టికల్స్ present in it are taking the energies. Okay, అయితే that absorbing energy or the releasing energy is not in the form. This is the main point in the quantum theory, that the emitted energy or absorbed energy is not in the continuous manner. The energy emitted by the emitted by an object or absorbed by an object is it is discontinuous manner. So means energy is discontinuous. This is important, discontinuous. Okay, so discontinuous manner. The releasing of energy or absorbing of energy not in the it is in the discontinuous manner, not in the continuous manner. Okay, in the discontinuous manner. And they also he also given a particular point. What is a discontinuous manner? And energy releases are absorbed in the form of small packets. It takes place in the form of small packets that known as energy packets are also called quantums. Okay, so energy released in the form of energy released or absorbed. Energy released or absorbed, that is in the form of small packets. So the small packets of energy are called quantums. Means each every energy packets are having some a fixed amount of energy. అంటే రిలీజ్ అయ్యే అంటే ఎనర్జీ కంటిన్యూస్గా రిలీజ్ అవ్వకుండా కొన్ని ప్యాకెట్స్, స్మాల్ ప్యాకెట్స్ ఫామ్లో రిలీజ్ అవుతుంది. at the small packets or the energy packets are called quantums or quantas. Some books it is given quantas or quantums. అయితే రిలీజ్ అయిన quantums are having same energy అంటే okay, they are having fixed amount of energy, but all are not having the same amount of energy. Some quantas are having more energy, some are having less energy. So after observing the energies of all that quantas, he also given a mathematical expression that the energy of quantas, the energy of that small packets is directly proportional to the frequency of the radiation. Okay, release a light frequency ke their energy is also proportional. The energy of the radiations emitted is directly proportional to their frequency. So that is E is equal to, by the removal of proportionality we can put a constant, that is becomes E is equal to h nu. So this is one of the best, so one of the highly used equation in the atomic structure, that is E is equal to h nu. Here E means the energy of the quantas are nothing but energy of the radiations. Nu means the frequency of light. So what is h? So here h is known as Planck's constant. H is known as Planck's constant. So he also given values for Planck's constant. So energy proportional to energy of the radiation directly proportional to their frequency, that is called E equal h nu. So here h is important, that's the Planck's constant. We have to remember the values of Planck constant is. So Planck constant mainly it is having two values, 6.625 into 10 to the power of minus 27 erg into second. This is not by second, so it is erg into second. That is 6.625 into 10 to the power of minus 34 joules into second. So generally erg into second is known as CGS method. This is known as SI method. Okay. So here one more important. So what is the units of this Planck constant? Erg into second. So joule into second. Second is the common one because time k. So time k main basic unit into seconds. Next erg. Erg is a unit for energy in CGS method. Joules is also energy unit in SI method. Means the Planck constant unit. So we can say it is having the unit like energy into time, because erg into second means joule into second, nothing but energy into time. Okay, next we can further write something to it. So E is equal to h. So already we know what is the relation. Just now we discussed about the nu is equal to c by lambda. Okay, in the relations already we know that nu is equal to c by lambda. So in the place of nu we can write c by lambda. So this is also equation. The main form is E equal h nu. From this we obtain E equal hc by lambda. So can you guess another form? E equal hc. What is this 1 by lambda? 1 by lambda plus we can write the nu bar, because we know that nu bar is equal to 1 by lambda. Okay, so these are the so this is about the Max Planck quantum theory. So what is the simple drawback in this theory is so it was applicable. It was said to be that Max Planck given his theory to explain the black body radiations. Next, afterwards Einstein. So afterwards Einstein given his approach to this black body radiation, this quantum theory, just which is applicable to all types of the radiations. Okay, simply we write it as Einstein approach to this quantum theory is she separately studied as Einstein's approach. So here we discussed that is E is equal to h nu. So E is equal to h nu. So the one more important point in the Max Planck quantum theory is E is equal to h nu. So the application system and other derivation system, other relations. Again, one more important point E is equal to h nu. H is the energy of a quantum. Already we said energy, all quantums are not having exactly same energy. Some are kapate annitiki a types of energy untade h nu type of energy untadi. H nu type of energies ante ఇప్పుడు some are having 1 h nu, some are having 2 h nu, 3 h nu, like that. But they are not like that 1.5 h nu, 2.5 h nu, 2.3 h nu. Means it can be written as E is equal to, this is a perfect value for calculations. E is equal to any h nu. So E equal to h nu endante this is only for one particle. This is only for one particle or one packet. Only one packet ke, one basic packet ke manaki equal h nu వస్తుంది. సో ప్రతిసారి బేసిక్ ప్యాకెట్ ఉండాల్సిన చాయిస్ లేదు. So some are having energy is equal nh, here n is equal to 1 2 3 small integers. So there is only integers are present, they are not fraction values are present. Okay, means the energy of the quantas always is in the multiple integer, is multiple integral of h nu, that is 1 h nu, 2 h nu, 3 h nu. It cannot be in fractions. Okay, so now we read the main points in this quantum theory. Okay, so it was proposed by Max Planck, and to explain the behavior of black body radiations. Okay, so next main point, absorption or emission. Sorry. Absorption or emission of radiation mainly due to the, this is the main important point, due to the vibrations of charged particles. Due to the vibrations of charged particles. Already we discussed all these points. Next, the energy absorbed. The energy absorbed or emitted are emitted from an object or by an object discontinuously. It's mainly totally in the form of a discontinuous, and it is in the form of a small packets. In the form of small packets of energy so as a radiation. So the small packets are known as the small packets associated with some energy associated with the definite amount of energy are called quantums. Okay. Now we see the mathematical expressions for it. So the energy of quantum of radiation is always directly proportional to its frequency. To the frequency of that particular radiation. E proportional to nu, that is E is equal to h nu. So very simple. H nu is equal to, we know, the C by lambda. So here one more relation we're having, equal to hc by lambda. So E is equal to 1 by lambda plus, so we can write nu bar, sorry, E equal to hc nu bar. Okay, so in the problems we are having we need some more relation. Some more relation means just with the help of relations we create some formulas. So take it equation 1, 2, 3. Again with the help of equation 1, so we can write E proportional to nu, already is given. So both are in the denominator. Here h is the Planck's constant. Here we can write even by E2 is equal to nu 1 by nu 2. So these are mainly useful in the next problems. Even by E2 is equal to. So lambda energy, this lambda is exactly inversely proportional. So that is lambda 2 by lambda 1. Next, if you see from third also, the energy is directly proportional to nu bar. So the E1 by E2 is equal to nu 1 bar by nu 2 bar. Okay. So here main factor, the main thing in the calculations, we have to know, we have to remember always about the Planck's constant. Okay, that is h is Planck's constant. The Planck's theory given constant, Planck's constant. So 6.625 into 10 to the power of minus 27 erg into second. So in otherwise you can write 6.625 into 10 to the power minus 34. So joule into second. So what is erg? So erg into second, this is generally treated as a CGS method. It is treated as a SI method. In the problem cell, so we have to get about the other details. Okay, so problem other details basis when we have to use a CGS or SI method, we have to select at that time. Okay, next see here 10 power minus 27, 10 power minus 34 joule cells. So with the help of this we can write 1 joule is equal to 1 joule is equal to 10 to the power of 7 ergs. Okay, joule is a bigger unit when compared to the ergs. Next, the one more important point, we can know it, the energy is emitted or absorbed is in simple integral multiple. Is in simple integral multiple of Multiple of quantum. So multiple of quantum means that is multiple of h nu, that is equal to the energy of the packets is equal to nh nu. Okay, so here n is equal to integers 1, 2, 3, they are not at all in fractions. So this is the total main points about the Planck's quantum theory, okay, which explains about the black body radiations. Okay, now we see the approach, the Einstein's approach. What is the extension of Einstein to this quantum theory? So just within 2-3 points we will explain it. That is Einstein's approach. So that is Einstein's approach. So what is so actually I just Planck's quantum theory was applicable only for black body radiation. So he applied that theory. He applied that theory to the all types of electromagnetic radiation, not only black body. This theory, he applied this theory for all types of radiations emitted from all types of objects. Okay. Next, what is the difference in this theory is in the place of quantums, in the place of energy packets, he given the energy emitted is not in the form of energy packets, they are in the form of small particles. Energy is released or energy absorbed is always in the form of small points, nothing but small particles, which are known as photons. Okay, means what is the similarities in this both theories is, so similarity ante we will get that discontinuous energy absorbed or released are in the form of a discontinuous manner. So రెండిట్లో continuous manner అనేది లేదు. So both agreed that energy is not in the form of continuous manner, energy released or absorbed in the form of discontinuous manner. But the Planck used the energy packets, nothing but quantums, but he used the energy particles which are named as photons. Next, remaining is everything same. The photon is also having energy is called h nu, same thing. Okay, but one more important, the photons, the energy particles are also moves in the form of waves. Okay, so now we write the points. Simply you can write he extended the quantum theory for all types of electromagnetic radiations. So according to his the main point is the radiant energy is which is absorbed or emitted in the form of small particles. Small particles, they're known as photons. Okay, so again here the photons propagated in the form of waves. Okay, and the energy of photon. Energy of photons is directly proportional to the frequency of the radiation. So that is E is equal h nu. It is also similar in the both theories. Okay, so for 1 mole of photons, so this is the formula is useful for further problems. For 1 mole, so for 1 mole of photons, for 1 mole of photons, it is E is equal to nh nu. Means this E is equal to h nu is so already we said in the quantum theory, in the Planck's quantum theory, that is for one packet. It is also, this is E is equal to h nu for one photon only. For 1 mole of photons, E is equal to capital nh nu. So we know that n is equal to number of moles, that is Avogadro's number. So n is Avogadro number. So what is Avogadro's number? 6.022 or 23. So it will depends on the book. 10 power 23 units. Okay. So generally in the problems we use these formulas. Okay. So in the next class we see the problems based on the relations between the wave properties and relation between the wave properties with the energy. Okay.